on to our next topic, that is equations for projectile motion. So we will consider a projectile motion like a football player on the ground, on the football ground, and he is kicking a ball. So he is on the ground, which is the x-axis, and this one is the vertical direction. Which one is y-axis? So initially the ball is at this position. Now at t is equal to 0, he has kicked the ball, and this ball is going in a projectile motion, and it is reaching the x-axis at this point. So he has kicked the ball with some angle theta and with some in this direction making angle theta, and with some initial velocity, say v I, and this, as it is making angle theta with the ground, so the horizontal component of the initial velocity is vi cos theta, and the vertical component is vi sin theta. Okay. Now during its flight, the only oscillation is in vertical direction, which is in the downward direction. That is, oscillation is minus g in the below the y-axis. So we can denote it minus g in the negative y direction, and there is no oscillation in the horizontal direction. So as there is no oscillation in the horizontal direction, and as we know v is equal to u plus at, so for horizontal motion a is 0, so v is equal to u. So let's first find out the range r. So we consider first a horizontal motion. So as you know, the equation is s is equal to ut plus half a t square. So as we have to find the value of r, we will apply this equation because it includes s. That's what we want. That's what we want to measure. So what is s? S is displacement. So displacement with respect to the x-axis or from the starting point. Now consider this projectile motion. So let's first calculate the value of r, the range. So to find the range, we will use the equation S is equal to ut plus half at square. So we will consider a vertical motion first. So in the vertical direction, first we need to understand what is S is representing here. S is the displacement of the particle at any given time t. U is the initial velocity and A is the acceleration. So here consider a vertical motion. So time it reaches at this position, vertically S is 0. I'm talking about the vertical, not the x, because at this point the y coordinate is 0 and here also the y coordinate is 0. That is the final position minus initial position. So here final position is 0. So vertically it is 0 at this time t here. So S is 0. So at the time it reaches here. And what is the vertical velocity? It is vi sin theta into time t. That is the time of the flight. Here we take as minus g because g is in the vertically downward direction. So I am taking half g t square. So I can rewrite this equation as t vi sin theta minus half g t is equal to 0. So that means t is equal to 0 and vi sin theta, either t is equal to 0 or vi sin theta minus half gt is equal to 0. So the displacement S will be 0 at t is equal to 0 and at t is equal to 2 vi sin theta divided by g. So what does this t is equal to 0 represent? At the initial point, at t is equal to 0, ball is at this position, so the S is 0, and here also at t is equal to 2 vi sin theta by g, the ball is here and again S is 0. So I have calculated t, and which one is same as the capital T. I can say the time of flight. So we are going to find R, but first we have calculated the time of flight. Okay. Now the range R, we have to find the range R. So we will write equation for horizontal motion. In horizontal motion, we have to find the displacement, that is the value of R. So value of R, so we know the equation S is equal to ut plus half at square. But the acceleration is 0 in the horizontal direction. So I can write S is equal to u. U is the initial velocity in the horizontal direction, which is equal to vi cos theta into t. So what is the time? The time the ball has taken to reach here. Which one is the time of the flight? So I can write here t. So which one is equal to vi cos theta, and I will put the value of t as 2 vi sin theta by g into this equation. So it is 2 vi sin theta by g. So I can rewrite as vi square 2 sin theta cos theta divided by g, which is same as vi square sin 2 theta divided by g, because sin 2 theta is equal to 2 sin theta cos theta. So we have found value of h and we have found the value of t, the time of the flight. Now we will calculate the value of the equation for that h, that is the maximum height achieved. So as we know, at the maximum height, the vertical velocity Vy is 0. So first we will find out the time it takes to reach the maximum position. So as you know, the basic equation is V is equal to U plus AT, whereas U, that is the initial velocity in the vertical direction, is Vi sin theta, and A, we have taken this one is upward as a positive, so, and acceleration is always in this negative direction, so we will always take acceleration as minus g. So Vy at any point is Vi sin theta minus gt. Now at the point it reaches its maximum height, that is at this point, Vy is 0. So solving this equation, we have to put Vy is equal to 0, and we will get t is equal to Vi sin theta by g. So this one is the time it takes from going from here initial position to the maximum position, maximum height. There is one more interesting observation here. Remember in our last derivation, the time of flight is what? 2 Vi sin theta by g. So that means the time it takes from here to here is Vi sin theta by g. From here to here is also Vi sin theta by g, and the total time is 2 Vi sin theta by g. That is just we have a symmetry here. So t is equal to Vi sin theta by g. So we have to find the maximum height, that is the vertical displacement of the particle at the time it reaches its maximum position. So we have to apply the formula for it, that is S is equal to ut plus half at square. And yeah, we can solve it by some another way also. As we know, V square is equal to U square plus 2AS. So it will be more simple if we apply this formula, I think. So yeah, by any way, if we put the value of t as Vi sin theta by g and acceleration as minus g, we will get our result as S, that is the maximum distance, maximum height achieved, that is h. We will go from the another equation, that is V square is equal to U square plus 2AS. So what is the final velocity when it reaches the maximum position? It is 0. U is the initial velocity in the vertical direction is vi sin theta, and acceleration is minus g, and s is h. So putting this value, what we will get? So we will get 0 is equal to vi sin theta whole square minus 2gh. So that means h will equal to vi square sin square theta divided by 2g. So this is my formula for the maximum height. Vi square sin square theta by 2g. Do remember one thing, the derivation of this term is very important because it will help you to solve the numerical problems. So we have find the value of h. Now we have to find the equation of the trajectory of this projectile path. So that is the equation in terms of x and y coordinates of the particle at any given time. So suppose I have given time t and I have to find the x and y position. Then what I will do? Okay. So we consider a horizontal the motion for the trajectory for the vertical motion first. So as you know, s is equal to ut plus half at square for horizontal motion. A is 0 and u is vi cos theta. So I can write s is equal to vi cos theta into time t, and acceleration is 0, so it is simply s is equal to vi cos theta t. That is the x coordinate at any point of time is vi cos theta t. Okay, so this is my first equation. Now I will consider a vertical motion. For vertical motion, what is value of a? A is minus g. What is value of u? U is vi sin theta. Okay, so for the vertical motion, that is the y coordinate at any point is y is equal to u is vi sin theta t minus half g t square. This is y coordinate at any given time t. So this is my first equation and this is my another equation. So I will eliminate the t from both these equations. So I will put here the value of t as from the first equation as x divided by vi cos theta. So I can rewrite y as vi sin theta into t. T is x divided by vi cos theta minus half g, and t square is again x square divided by vi square cos square theta. So it will be x tan theta, sin theta by cos theta is tan theta, minus half g x square vi square and cos square theta. So this is the equation of the trajectory of a projectile motion. And if you watch it it closely, you will see this is the equation of a parabola. So we have an equation of parabola as that the trajectory of this projectile motion as y is equal to x tan theta minus half g x square initial velocity vi square cos square theta. So now moving on to our next topic, that is some interesting observations regarding projectile motion. So as far as we have derived lots of equation, the equation for the maximum height h, the range r, and the total time of the flight. So we will list down what are the interesting observations we have come across. So first of all, we have this formula for maximum height, for the range, and for the duration, total duration of the time. So first observation, that is observation number 1, we will name it, is the time it teaches to attain at the maximum height is half of the total time duration of the flight. That is TH time to attain the maximum height is equal to T, that is the total time of the flight, divided by 2. Okay. Now we will take some special cases of theta. So take a case of theta when theta is equal to 90 degree. So what will happen when theta is equal to 90 degree? So put the value of theta is equal to 90 degree into this equation. What we will get? We will get h is vi square 2g, because sin 90 degree is equal to 1. We will get range as theta, we put 90 degree, and 2 into theta is 180 degree, so it will be 0. And the total time of flight will be 2 vi, sin 90 is again 1, it is 2 vi by g, for theta is equal to 90 degree. So this is the same case when the ball is thrown vertically upward. So this is a special case of a projectile motion when theta is 90 degree. So now take another special angle, that is at theta is equal to say 0 degree. So at theta is equal to 0 degree, what will be the h? Sin theta is sin 0 is equal to 0, so h will be 0, r will be 0, and the total time of flight will be 0. So why it is so? So say if I am throwing a ball in this horizontal direction, so it will no longer be a projectile motion because it will cover this path, and we have other force will come into the action, like the frictional force of the surface and the reaction of this surface, it is R here, and the frictional force F. So but as you know, in the projectile motion we are studying the on the only force, the gravity force. So it won't be a projectile motion. And as soon as we will throw it with some initial velocity vi at angle 0 degree, so it will again come here, just in this ground. So time of flight is obviously 0, and the maximum r when it reaches the same initial height is again 0, and h, the maximum height attained, because there is no vertical component of the velocity which will lift this ball in the upward direction. So the maximum height h will be the 0. So we have understand the special case when theta is equal to 90 degree and when theta is equal to 0 degree. Now we will take a special case of when theta is equal to 45 degree. So when theta is equal to 45 degree, you know sine 45 degree is 1 by root 2. So h will be 1 by root 2 square is 1 by 2. So it will be vi square divided by 4g and r. So at theta is equal to 45 degree, sin 2 theta is 90 degree, and range will be vi square divided by g. Sin 90 is 1. And the total time period will be sin 45 degree is 1 by root 2. So it will be 2 vi by root 2 g, which can be rewritten as root 2 vi divided by g. So this is a special case when theta is equal to 45 degree. And this one more interesting observation is here. So a question comes when the range r will be the maximum. So at what angle theta we should project a projectile with the given initial velocity vi, so that it will cover a maximum range r, is when theta is equal to 45 degree. Because as you know, the sine function attains its maximum value at when the angle is 90 degree. So this factor 2 theta will be 90 when theta is equal to 45 degree. So our maximum range possible is vi square by g. Now there is one more interesting observation is if there are two projectile motions are there, consider this x-axis which is making 45 degree, and if I throw or projected two stones from here and from here, which are making same angle theta with this axis, which one is at 45 degree. So the interesting observation is the range will be the same for both these projectiles. So let us see why. Because as you know, this one is projectile 1 and this is projectile 2. So projectile 1 is making angle of theta plus 45 and projectile 2 is making angle of 45 minus theta. So for projectile 1, the range is vi square sine 2 of this angle, so it is 2 theta plus 90 degree divided by 2g. And for the projectile P2, formula is vi square sine 90 degree minus 2 theta divided by 2g. But as you know, sine 2 theta plus 90 and sine 90 minus 2 theta are same. Which is cos 2 theta, and it will be a cos 2 theta. So range will be same. So r is equal to vi square cos 2 theta divided by 2g. So we have seen the two projectiles being thrown at the same angle theta with a 45-degree axis. Their range will be the same, which is equal to vi square cos 2 theta divided by 2g.